We're going to be talking about albedo and feedback. Now, you've heard these two terms before, and we've talked about it a little bit, but we're going to go more in depth into this today and for the coming week. Again, you will have two assignments. The two assignments will be due next Tuesday at 11:59 p.m. Anyway, let's get started. So ice albedo and feedback. If you remember, albedo is the word we use when we talk about the reflection of light without actually it going through the absorption of energy and the re-radiation of infrared energy. If that all sounded like a bunch of words to you and you're not paying attention, that means you have not woken up enough, and also I'm not showing you the figure. So here's the figure. Okay, so if we look down, see the sun coming through. That's an external influence. It goes in through the atmosphere. And then as it does so, if it hits ice, the ice reflects the light, and the yellow means that the light is reflected. If it hits the Earth's surface, i.e. water, which is of course darker, more like a black body, and melting permafrost, this actually would be the area like in the tundra, where if you take the snow off, it will actually turn brown, which is darker. In any event, there's a couple of basic ideas going on in this figure. The first of these, of course, I just mentioned, is that the reflection, or the albedo, is present from the glaciation, right? So that's reflecting a lot of the sun's energy back into space. Whereas if it's absorbed by the Earth's surface, as we all know, the Earth's surface will absorb that light energy, wiggle around a little bit, and then re-emit it as infrared light, also known as heat. So if you have more albedo, you have less energy reflected into space, as it says there. This business over here, as we know, there's a couple of things. Now, you may think that the CO2 and the methane, which is what these are here, being released is due to us, but that is not only the case. So the more we look at this global warming problem, the more of a nasty or wicked problem it becomes, because as we melt the ice, we get less albedo, more heating, which melts the ice. We all know that's a nice positive feedback loop that we got there. We also, in addition to melting the ice, making more absorption, which is shown here, that's one thing. But the other problem that happens when we melt the ice is all the CO2 that was trapped in that ice that we learned about from the ice cores. Remember, the CO2 is down there. Well, then that's released from millions of years ago, or thousands of years ago, as the case may be. And then also there's lots of methane, which happens to be in the permafrost. So this is from organisms that have been living in the permafrost, or did live in the area before it was permafrost. Then they got frozen. They stopped making methane. But then when it gets unfrozen, the decay makes tons of methane, and they start releasing it into the atmosphere, which of course further warms the atmosphere, which melts the ice, which further warms the atmosphere, which also releases more CO2, which melts more ice. You get the picture. That's positive feedback. We've seen it plenty of times. What are we doing? Okay, so here is a nice little video that will show you maybe a little bit more succinctly. Plus, it has pictures outside. So I will go ahead and roll that for you now.
Systems can shut down or spin out of control. These are called feedbacks, and they can have global scale consequences. Julian Struve studies the reflectivity of surfaces, which is called albedo. Exploring huge expanses of the coldest regions of the planet, she's found that altering the reflectivity of snow and ice has wild effects on global systems.
So Ryan, as you can see right here, the snow is very, very bright, which means it's reflecting most of the sun's energy back out to space. And we use a term called albedo, which basically defines how much of the sun's energy is coming in versus how much is being reflected back out by the surface. Let me show you something that's pretty important.
All right.
So check this out, Ryan. Here's a really good example of the differences in the albedo between rock and snow. Because since the rock has a lower albedo, it's been absorbing a lot of the sun's energy, heating up and melting back the snow that used to be next to it.
So the rock is heating up And when the rock heats up, it melts back the snow. And so when the snow melts back, it exposes more rock, which heats up a little bit more, melting back more snow.
Well, basically, since large parts of our planet are covered by snow and ice, if the planet warms, we're going to be melting back that snow and ice and exposing darker surfaces such as rock or the ground.
Would you expect to be able to go to these polar regions where there's a lot of snow and ice and see this ice albedo feedback happen?
Well, we are seeing that happen predominantly right now in the Arctic region, where we've seen large changes in the amount of sea ice that's covering the Arctic Ocean.
What are the implications of rapid sea ice change in the Arctic?
You're going to warm up the Arctic even more than you would if our sea ice was there. The fact that the Arctic is cold, the equator is warm, that drives all of our atmospheric and oceanic circulation patterns. So we're looking at changing all of our weather patterns.
Wow. Thanks so much for your time.
You're welcome.
That was really cool.
Okay, so that was that video. Moving on. What are we going to do this week? Number one, there's an activity to do that's actually related to that from, I think it's from University of Colorado at Boulder. In any event, here is the activity. So as it says right there very clearly, it only works in Chrome, which means, yes, it only works in Chrome. I tried Safari and Firefox. They are plug-in, blah, blah, blah. You don't like it. So I'm going to go ahead and this PowerPoint will be available to you. So you can go ahead and click through there. If you click on here, it will bring it up. Hold on. Okay, so once you've clicked on that, it'll bring you to here. Remember, you have to be in Chrome for a couple of regions. Safari and Firefox, you will notice, do not show the pictures like. All right, so here you'll read this first one, basically going over just the difference in albedo. Alpha is the albedo. You can see it's higher. Medium, much lower. The next one is going to, once you click on the next one, what happens is you see down here, it's actually downloaded a movie. That should play on your computer. It is a QuickTime movie. I'm not going to do that right now, but basically what you do is you click on it, and it will come up and convert, and then you can play it. And so I want you to do that for all, I think there are 4 of these, okay? So anyway, that's there. The other thing that you can do when you go through this little activity, you're going to read it. And then you also need to show the diagram each time. So this is going to show how the solar energy is coming. Melts the snow and ice, ground's exposed, heat absorption, and that is a type of feedback loop that we are all well aware of in this class. Next, same thing. See how the video came down? I'm not going to go through and open all of those. If you have problems running the videos, you can probably definitely do the assignment without them. However, I will go ahead and upload copies of them. They're QuickTime movies. So QuickTime is the movie player on your computer that it should just pop up. Okay, so then this is talking about soot. So this is something that we haven't seen before. And then you can click over here. Don't miss these right up top. And then effect on glaciers, another movie. Another diagram, sea ice. One movie. Snow diagram on this one. And then another movie. Okay, so that's one of the activities. I want you to do this. And then the assignments are going to come up later. I'll show you. We're going to go back to the PowerPoint now. There you go. Okay, so that's the first activity. Second activity, which is the assignments. Stuff to hand in, that is. It's still an assignment to do it. But anyway, I want you to do basically 2 things. I want you to use your computers to research Arctic amplification. Now, I haven't discussed Arctic amplification, but you can probably guess what it means from our discussions of the positive feedback loop that exists there. So what I'd like you to do is one of 3 things. You can draw and take a picture of the drawing. You could use slides, like I'm doing now, or you can use this guy. Remember this guy, the Understanding Global Climate Change, right? So you could use him too. In any event, whichever way you choose, I want you to make a model that addresses the following questions. So you remember the model is like a hypothesis that you're going to use to be able to explain the phenomenon. That phenomenon, of course, is the albedo. and the warming. So how does Arctic amplification correlate with the concept of albedo? You're going to have to look for that. The other one is explain why warming is happening at a faster rate at the North Pole than the South Pole. Now, this is something that you're going to have to look up and think about and talk about. So on your model, whether it's the drawn model, made in slides, or made using the module that we've used before, I need you to have written explanations of how your model is addressing these two questions. And so these are the two assignments. Look it up, make it, and then do the writing about these questions. It will be submitted all as one document with the questions in it. You're going to submit it on Google Classroom to this post, and that should be it. As always, I will respond to your emails as quickly as possible. If you email me right after this, I will get back to you pretty much immediately. Also, if you have any other questions about anything at all, really, feel free to email me whenever you can. And I hope everybody's staying safe and doing good. I will talk to you later.